Hi guys, in this video we're gonna make a different kind of control circuit that uses the three-phase induction motor, and with the press of a switch you can start rotating it to the left and then to the right. First off, we're gonna start like the last time. We have our three-phase power supply, our motor, and then we add some components like contactor, start button, stop button, and then also normally open triple contactor. So as you can see, we tried to connect all the three phases to the contactor, and then through the contactor we go to our power supply, or in this case three-phase main supply. And then we also need, since we have one phase here, we can rotate this one and we can name it stop. This one is start. Rotate it. And we have we're gonna put it as KR, as in contactor that goes to the right. And the last thing we need is, this one is also KR. Then we need a neutral conductor to make all this connected. So we have a contactor coil, goes like this. Then we have a start button that's normally open, and we have this, and the stop button goes to one of the phases. So when we play the simulation, when we press the button, it will start rotating on one side, and as in the last video, we need to keep pressing it so it will work. We now also need to add a normally open contact. Normally open contact. We need to rotate it 90 degrees and then make it parallel to the start button. Like so. And we also choose K right. Now, when we press the play simulation, when we press the button, it will start rotating on the right side. When we press stop, the whole thing stops. Now, we need to do another thing, as to make the motor go on the other side. That's a simple thing to do, as all you need to do is change over two phases. So we go with the normally open triple contact. As in the three-phase system, when you change two phases, it changes the way the magnetic field rotates. That's a little bit of a theory for motor control. So we have here three phases. We just connect them like so, and then we can go, first phase goes to the second one, second one goes to the first one, and the third one goes to the third one. this way we change the rotation of the contacts of the motor. Now all we need to do is add another start circuit that goes to the left. We need another start button. We're gonna rotate it. And we're gonna name it start left. And this one we can call start right. Now we need another normally open contact. And we need another contactor coil. We connect it like so. My bad. We should name this contactor left. This normally open contact also contact left. And we just all connect right here, as it's all parallel connections, like so. And we also need to put this as contactor left. Now what will happen when we press start button, start right, it will go right. When we press start left, I will demonstrate there will be a problem with the circuit. So we press start right. You see it goes to the right. When we press start left, it creates a short between the phases. This is really bad for any type of instrument or any type of circuit. So what we need to do is, once one of these is started, the other one shouldn't work. We do that by using normally closed contact, like so. We put it here. And the other one also on this side. Doing it this way, it means that it will prevent the short circuit that we had a little bit before. We choose this as KL, as it means when KL is used, this one will open and the KR will not change over, or it will not start using this contactor here. And this one will go as K right. Now it should all work. We press play, we press start right, it goes to the right. We try to press start left, nothing happens. The circuit works. When we want to go left, we press stop, the whole circuit stops. Then we press start left, it goes to the left. We press start right, it will not work. This is just a simple demonstration. Now I will just show you a bit more of a circuit, how it should look. This is the circuit. Like last time, we have 3 phases, neutral and a protection earth. We have a main contact here that needs to separate the rest of the panel from the grid. And then we go here, we have some fuses. This is fuses for the motor, this is fuses for control circuit, and this is for some simple signalization. We over here have a motor starter, or someone calls it overload protection, depends on the region where you're from. This one is mechanical, and it also has an overload feature, as in bimetal feature. Then we have 2 contactors, right, left. In this case, I changed them over here. On this side, not on this side, like in the simulation. We have a motor here. And then we have a simple control circuit, like I already said in the simulation, except we only have here this F1s, that is the motor protection. When it closes, this closes, so you can use the control circuit. If this trips, this will open and everything will stop. There will be no voltage in this section here. That's also here why we have F1. This is only to show that there is some type of error on the motor, that it had too much current at some point in time, and that mainly means you need to check this here. If this looks okay, then maybe you should check the fuse breakers, and if all of this looks good, if you start again the motor and it pops again, it means that there is some greater problem with the motor. It can also be the contactors, but in my opinion most of the time it means that maybe the bearings of the motor were bad, or they just started going bad, and then do all the more friction that is caused by bad bearings. It cannot work at its nominal current, and then it draws more. That's usually the case, and then you need to take off the motor, replace the bearings so none of the windings get damaged. Overall, this is a simple circuit. If you have any questions, please leave them in the comments. Do subscribe, like, and I hope I will continue to make more of these kinds of videos that maybe can help some of you. Thank you, and have a nice day.